Hello everyone and welcome back to the C++ 3D game tutorial series. In this 39th video tutorial, we will see how to create the fog. In particular, we will see how to create the fog component, how to render the fog effect through the shaders, and in the end, we will see how to use the fog effect to create a dawn scene. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create the fog effect. Let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. Before to start, let's see what is the fog. The fog is a thick cloud of tiny water droplets suspended in the atmosphere at or near the Earth's surface, which obscures or restricts visibility. In order to render such effect, we have to exploit the shaders and some math formulas. In particular, we can compute the fog amount with math formulas like linear fog, exponential fog, and other kind of formulas. Today we will face the linear fog. We will deepen the other kinds of fog's formulas in the next tutorials. In a few words, the linear fog formula is the following, where start is the distance at which fog effects begin, and is the distance at which fog effects no longer increase, and d represents the distance from the viewpoint. In our case, this value is the distance between the camera position and a vertex. In the end, with this kind of effect, we can add a sort of atmosphere to our game. For example, in the scene, the fog is exploited in order to create a colorful dawn atmosphere. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's go to the entity folder and let's add the fog component class. As usual, let's add the constructor and virtual destructor methods. At this point, let's extend fog component class from the component class. What do we have to do now? Well, we have to add the onCreateInternal method and add and remove this type of component to and from the graphics engine. In the end, let's go to the graphics engine header file and let's support the fog component, as we have already done with the other components. Let's remember to add the forward declaration to fog component class in the prerequisites header file. So far so good. The next step to do is to add the attributes of the fog. For now, let's add the color of the fog and the start and end attributes that we have just seen in the introduction. As usual, let's add the setter and getter methods. Very well, it's the turn to create the fog effect in the shaders. So let's go to the common shader file and let's start to add the fog data structure. Here let's add the attributes just added to the fog component class. Let's also add a further attribute called enabled that should indicate if the fog effect is enabled or not. In the end, let's add an attribute fog data inside the constant structure. What else? Well, we have to create a function called computeFog, in which we have to use the linear fog math formula seen in the introduction. Let's also apply a clamp function in order to clamp the resulting value between 0 and 1. Last but not least, let's add the computeFogColor method. As we have just seen in the introduction, the distance attribute represents the distance between the camera position and the position of a specific vertex. To compute this distance, we have to subtract the camera position from the world position of the vertex. Then, the distance is the magnitude of this vector that we can compute through the length function. At this point, we can compute the amount of fog through the function just created. In the end, if the fog effect is not enabled, let's simply return the color of the scene. Otherwise, we should make a linear interpolation between the fog color and the scene color, with an alpha value that is exactly the fog amount just computed. Very well, let's start to compute the fog color in our shaders. All we have to do now is to reflect the fog data structure added in the shader in the C++ counterpart. At this point, in the update function of the graphics engine class, we have to manage the fog components. Since we support only one fog component, if we enter the loop, we enable the fog effect and we pass the various fog attributes to the fog data structure. That's all. We don't have to do nothing but to go to my game class and in the onCreate method we have to add a new entity with a fog component. Let's remember to add the fog component header file in the all header file. For now, let's remove the skybox. Let's see if it works. And it works! Let's change the light color in my game class. And let's also go to water shader and let's tune the various values of the specular lighting. That's all for now, folks. Today we have seen how to create the fog effect. I hope you enjoyed this video. See you soon. Thanks for watching.